A passenger jet cruises at nearly 900 kilometers per hour. The dashboard flashes the number, but the pilot does not call it kilometers. He does not say miles per hour. He says knots. It is the exact same word a sailor used 400 years ago while standing on a wet, rocking deck, dropping a wooden board into dark water. On the surface, it looks like stubborn tradition. We have satellites, we have flight computers, we can track velocity down to the decimal. So why keep a measurement born from rope and sand? The answer is not habit. It is geometry. And the knot is not an outdated relic. It is a navigation system designed around the shape of the Earth. Picture the open ocean 3 centuries ago. No radio, no radar, just wood, canvas, and endless water. You need to know your speed. Guess wrong, and you miss land. You run out of fresh water. You drift into nothing. Sailors solved this with a simple, heavy trick. They carved a triangular piece of wood, weighted it, and tied it to a long hemp rope. They tossed it overboard. The board caught the current and stayed almost still. The rope paid out as the ship moved forward. The sailor flipped a small sand glass. As the grains fell, he let the line run through his bare hands. He was not counting seconds. He was counting knots tied into the rope at exact intervals. When the sand hit the bottom, he stopped. The number of knots that had slipped past his fingers told him exactly how fast the ship was moving. It sounds almost too simple to work, but the spacing was never random. Those knots were carefully measured to match the Earth's own grid. Map makers had already divided the planet into degrees of latitude. They broke each degree into 60 minutes. They needed a distance unit that actually lined up with those lines. That is the nautical mile. 1 nautical mile equals exactly 1 minute of latitude. Think about that. A land mile comes from Roman footsteps. It works fine on paved roads. Ships and planes move across a curved planet. If you use a standard mile over water, your navigation math falls apart. You have to constantly adjust for the curve. The nautical mile skips that headache entirely. It locks your speed directly to the grid on your chart. And this is where the system gets interesting. If a ship sails at 60 knots, the navigator knows almost instinctively how far they will travel in an hour. They cross 1 degree of latitude. No complex formulas, no guessing. The speed and the map speak the same language. You watch the rope, you read the chart, you plot the line. It was a survival tool. A wrong knot count meant missing a safe harbor. It meant hitting unseen reefs in thick fog. Sailors lived or died by that number. But that still does not explain aviation. Why are jets using it? Because the sky has the exact same problem. Early pilots quickly realized the sky offered no clear routes, just open sky above a curved planet. When they flew out of sight of land, they borrowed everything from sailors. They used paper charts, they drew grid lines, they measured speed in knots because it was the only system that made sense over featureless ground. Radar came later, GPS followed, but the math underneath never changed. Satellites track positions using the exact same latitude and longitude grid. A commercial jet cruising at 450 knots is moving through a planetary coordinate system that matches the charts. Switching to miles per hour would not make flying safer. It would just force every navigation chart, every flight computer, and every air traffic controller to constantly convert numbers. At 30,000 feet, pilots need calculations they can trust instantly. Listen to a cockpit when the weather turns rough. The engines hum, the radar sweeps, the pilot checks the airspeed indicator. The needle sits steady on a number measured in knots. He is reading a direct translation of his movement across a curved surface. The same logic that kept a wooden schooner from vanishing in the Atlantic keeps a metal tube from drifting off course over the Pacific. The rope is gone, the sandglass is gone, but the geometry remains. Most of us think speed is just a measure of how fast an engine pushes us. We see it on car dashboards. Tires spin, speedometers tick. But cars follow engineered roads. They do not need to track their position against a sphere. Ships and planes do. They navigate through empty space. They need a unit that syncs with the planet. That is what a knot does. It ties velocity directly to the Earth's surface. Every time a navigator marks a position on a chart, they are using that same old system. It survived not because people refused to change it. It survived because it actually works better. The planet is curved. The grid is fixed. The knot matches both. Next time you hear speed reported in knots, do not just file it away as old sailor talk. Picture the dark water. Picture the heavy rope paying out. Picture a pilot checking a screen in a quiet cockpit. They are all doing the same thing. They are measuring their movement against the Earth itself. Long before satellites could track anything from space, humans figured out how to use the Earth itself as a ruler. We built our routes around latitude lines. We built our speed around the curve. And as long as we are traveling across an ocean or through the sky, we will keep counting knots. It is not about holding on to the past. It is about staying on course across oceans and open skies.